Here we want to be continuous and differentiable everywhere. So we're not going to pick up our pen to draw it. We're not going to do any sharp corners. We're not going to make a vertical tangent. And we want to follow along with all of these things. So interpreting each piece. First derivative being negative means decreasing. Second derivative being negative means concave down. And that's all from negative infinity to 0. And so up until 0. And then we switch from 0 to infinity to being, well, negative first derivative is decreasing. And a positive second derivative is concave up. This one, as long as we know concavity, we're just going to use some u's to draw it. So we don't even need to try to make a sign chart like we did when there was a lot of intervals. We can just think about what part of the u it has to look like. So the first piece is concave down. It's concave down and it's decreasing. The decreasing doesn't help me, but it helps me pick the right picture. So concave down is what shows me the shape. It's an upside down U. It's either the full upside down U to be concave down. Concave down could look just like the left side or only like the right side. And I want to think of which one's always decreasing. So this one is rising and then it's falling. This one's always increasing and this one's always decreasing. So which picture should I draw? The first, the second, or the third? For concave down and decreasing, it's the third picture. That's the first part of the shape I want to draw. I don't have anywhere in particular that I have to draw it. I'm not given a point that I have to go through. It's not like it says f of 3 has to be 4 or something like that. I just need to draw this from negative infinity to 0. So I'm just going to choose a random point that I go through. I'm just going to go through the point 0, 1 and draw this shape so that it's decreasing and concave down. I'm going to draw the same shape but over here. So it's going to be decreasing and concave down. There's the first half of my graph. There's partial credit. The next part says I need to be decreasing still, but I need to be concave up. So let's draw our U's for that. It needs to be concave up, and we want to choose the one that's decreasing. Concave up can only look 3 ways. It's a full U, it's just the left side of the U, or it's just the right side of the U. So I want to pick the one that's decreasing, so the one that's falling. This one's falling, but then it's rising, so it can't be a full U shape. This one's always falling, this one's always rising. So which one should I pick for decreasing? The first, the second, or the third picture? I should pick the second. Make sure you're drawing these U's in your notes. Otherwise, you're going to go back to study for the cumulative final and be like, I have no idea what you were doing. So give yourself a break and at least put these U's in there. That's how we're picking the correct picture. We're not just randomly throwing something on a graph. We need some side work. So I'm going to draw this shape, but bigger. I'm going to connect it because it has to be continuous. That's what it says up here. It has to be continuous and differentiable. So I'm going to switch to being oriented upward while still decreasing. That matches all of the pieces. So it's decreasing everywhere, but it switches from being concave down to concave up at the x value 0. So that's how I knew to switch at 0. If it said 3, I would shift it over to 3. Okay. The next piece is a little bit different. It says you want to be continuous and differentiable everywhere except at x is 2. So at x is 2, I need to make sure I'm not continuous or I'm not differentiable. So I need to violate one of these two, continuity or differentiability. So we really have 3 options. I can draw it so that it's discontinuous. That would make it so it's not differentiable and also not continuous. I could draw a sharp corner or a cusp. That would make it so it's not differentiable, and that would be good. That's what it wants. It's either not continuous or not differentiable there. And then the last thing I could draw, which I probably won't because it's really difficult to draw, is a vertical tangent. It's hard to draw a vertical tangent and then still have a function. So I probably won't do that one, but it's an option. If you're fancy, you can use it. And I want to follow whatever it asks me to on here. So the first thing it says is make sure f of 2 is negative 1. So what does that mean? It's just a point. F of 2 is negative 1. So I'm going to put that point on there. I'm going to at least go for partial credit. Even if I don't know anything else, I know how to draw a point. There's some partial credit. 2, -1. And this is the part that gets a lot of people. Is that point correct? No, 2, -1. This happens a lot where everything is perfect. It's all the right shape and you worried so much about the calculus that you got to get the point right. 2, -1. Now we've got some partial credit. Next piece says f prime is bigger than 0 from -infinity until 2. It's f prime, so first derivative being positive means it's increasing. I'm not going to do much with that quite yet because increasing and decreasing don't tell me too much about the shape. So this first derivative from 2 to infinity is decreasing. And the last piece I have is the second derivative is concave down. From -infinity to 2, union 2 to infinity. Well, let's see. We could use concave down in each of these pieces, or we can go back and make a sign chart before using the U's. Let's make a sign chart for this. You don't have to, but it might help. So it's increasing before 2. So -infinity to 2 is before 2. And it's decreasing after 2. So I went from increasing to decreasing. Should I have a relative max, min, or neither there? Should look like a relative max. There's the general shape of the graph. That should match what the second derivative sign chart looks like as well, because they're the same functions. They should have matching sign charts. So this second derivative is negative before 2 and negative after 2. So the whole thing is concave down. It's concave down while going from increasing for f prime to decreasing for f prime. Our graphs, our sign charts, they match. Increasing to decreasing while always being concave down. So I could literally draw this same shape onto the graph, but I also want to remember to make it not continuous or not differentiable there. So I might not draw it as like a nice, smooth, upside down parabola, because then it's going to be continuous and differentiable, and I'm not supposed to be. So I'm going to go through this point, and maybe I'm going to draw a sharp corner there. That would make it not differentiable and still facing downward. So I'm going to show you this option. You don't have to draw it in if you don't want to, because I'm going to show you a couple of them. So here's one option. It is face down, which is good. It's increasing to decreasing, which is good. It goes through the correct point, and it's not differentiable because it's a cusp. So one option, I'll draw it off to the side, would just be putting a cusp there. Another option, I'll do a couple on this one because there's so many different answers for all these, but this one's at least pretty interesting. So at the point 2, -1 that I have to go through. And I could maybe go like this and put an open circle up here or something like that, make it discontinuous. Or I can kind of do the best of everything, go through the point and have a discontinuity, and this is usually how it would look. Go to that point, but have the open circle be on the graph. So a bunch of different ways. Maybe I'll settle with that one. It's increasing to decreasing. It goes to the point 2, -1, and it's definitely not continuous, so it's also not differentiable because there's that removable discontinuity. So you could do a cusp. This is one great answer. Or you could do that removable discontinuity. Totally up to you. You can also do a vertical tangent. I'm not even going to show that because I think it's too hard.